Hi, thank you so much. I'm here today to talk about lab experiments, and while I can't promise that I will have much, if anything, to say about health, I can certainly talk about my experiences conducting experiments on and within networks and in the lab, or as is becoming increasingly common as a result of the pandemic, the online lab. But before I start on the nitty-gritty of experiments and tell you why they're so fantastic and what you could do with them in your own work, I'll give you a brief overview of what exactly I mean by experiments, and then, like a good experimentalist, I will plug them and tell you why they're so great, and maybe take the opportunity to defend them a bit if there are any of my reviewers out there in the audience. You almost certainly know the basic idea, right? So what experiments are. So the researcher manipulates some explanatory variable, or it can be more than one variable, but usually just a few. It's best not to get too crazy. And then you're observing the effects in some other variable, the outcome of interest. One of the gold standard examples of this is actually in medical research. So it's the administration of either a drug with an active ingredient, or like a placebo pill to observe whether the drug causes weight loss or cures some disease, or prevents hospitalization from COVID, whatever it is. And when you do that, you also hold constant all of the other variables that could possibly be out there. So all participants get a pill. That's why you have a placebo. It's the same color and size and shape. It's given by a doctor. All of that stuff is the same. The only thing you've manipulated is what's inside. And experiments are a particularly useful method because one thing that can be a challenge for people that are studying networks or collecting observational or survey data is that when you conduct your work and you submit it or present it or publish it, some critic, some reviewer can come back and say, well, is this effect real? Or can you actually infer anything causally from what you're looking at here, or is what I'm looking at a correlation, right? And typically, like, the former is more exciting than the latter. We want to establish causality, typically, in our work. You might get feedback from the reviewer to go off some of the things that I think Sherrick mentioned too, that maybe actually what's happening is that, like, you're trying to say X causes Y. In reality, I, as your reviewer, think that Y is causing X, and things are reflecting back onto X. Or there might be some third variable Z floating out there in the world that's causing your X-Y relationship to look the way it does. You can address these issues, these critics, in other ways. So you can do longitudinal or lagged models were mentioned earlier. If you look at what happens on time 1 and then see how it predicts what happens at time 2, it's a bit more difficult to argue the reverse causality argument. You can throw ever more control terms into your models to get at all these third factor Z's that any reviewer could possibly come up with, until eventually your critic, comes up with some that you haven't captured. Or you can do an experiment to test that X-Y relationship in really a neat and clean way. And a classic example in regards to networks, which again, Sherrick mentioned as well, so there's consistency, that's great, is this issue with cleanly assessing peer effects or influence effects, which can be confounded with other things, including homophily, as I have up here. So I study cooperation and pro-social behavior, basically what makes people be nice to each other. And one common theoretical explanation for how cooperative behavior might have evolved is that people can identify and selectively choose to interact with fellow cooperators, right? So the idea is that if you are a kind person and you go out there and you interact with people just purely at random, you'll get suckered, you will get screwed over because you'll be interacting with jerks, about half the time, or whatever proportion of jerks are out there in the world. Maybe depends on your point of view there. But whatever percent of jerks are out there in the world, that's how many times you'll get suckered. And that does not bode terribly well for cooperation evolving. Instead, what might happen is you'll get influenced, and you might turn into a jerk yourself. You'll take on the dominant strategy there. But if people can selectively interact, or select and selectively interact with fellow like-minded cooperators, then what this ends up doing is allows cooperative clusters to form. They're kind of insulated, they're protected from the jerks out there in the world, and cooperation can flourish. Meanwhile, jerks kind of are left to go it alone or interact with fellow jerks. They're the only ones left to hang out with. So how do we test whether and how those processes play out? Well, if you want to know whether nice people hang out with nice people and jerks hang out with jerks, you can observe that easily enough. And past work suggests that indeed that's what you will observe, but what you will find it much more difficult to do is to untangle the causal direction here, the process by which this is happening. So is it because of your theory? Are people able to go out there and selectively interact with other people that are similar to them in terms of their cooperative behavior? Or are people forming ties and then influencing their ties to become more like they are? Or are both happening? And if so, how much of this is attributable to each factor? On the flip side, not as someone who studies cooperation and prosocial behavior, but as a parent of a 5-year-old in preschool, I'm very interested in this work on conformity and peer pressure and influence. So that part of the story rather than the homophily part of the story. We all hear as parents, you don't want your kid to be hanging out with the bad crowd, the aggressive people, to take the language of the preschool study we heard about yesterday. True story, I have a kid who has a friend that I think is maybe not so great, and every time my kid comes home with like a new swear word in his repertoire, or I see this friend like throwing dirt at people at pickup, I worry because it's hard to disentangle. Is this kid going to influence my kid to do that? And that's, of course, what I think is happening. Or is this friend and my kid friends because my angel of a child engages in similar behavior? Or even worse, the reflection problem, right? So is my kid the bad kid and is actually causing the friend to be bad? Now, experiments can help us assess peer effects that we might be interested in as a researcher or as a parent. They can help us disentangle these things. And how they do it is these two hallmarks that make them special, not only because experiments have them more than other methods do, but because they're what help us establish causality. The first is random assignment of our participants to experimental conditions, or the level of the independent variable. So say you're interested in the ability for people to spread information to their network ties, to tell their ties about other people's cooperative or selfish behavior in networks that they didn't see firsthand, or gossip. That's a project that I'm working on right now with Tom Wolf back there. Hello, Tom. On the one hand, opportunities to spread information about what other people are doing in the network. So to tell Angel, sorry, you were the guinea pig in the last one, you were the guinea pig again today, to tell Angel all of the bad things that Jim does, and you were not able to see Jim, and now you know that there's someone else out there in the network that's doing these horrible things. Sorry, Jim. It could be that this is very bad, right? So if I tell Angel about all these bad things I see in the network via gossip, this could cause selfish, jerky behavior to spread throughout the network, become contagious. On the other hand, it's possible that opportunities to spread information or gossip in networks could be really beneficial to networks because people don't like to be gossiped about, so they might be better as a result if they know that I can tell Angel about what you're doing. So in our study, we randomly assigned networks to be able to spread information about their ties, cooperative or selfish behaviors, or not. The reason we do this, I've even got the coin flip picture on here. We talked about coin flips last time. So we've covered it very well, but just to refresh your memory from a couple minutes ago, the reason that we randomly assign folks to experimental conditions is because participants have idiosyncrasies, and you want those to be distributed across your conditions about equally. It's not perfect. It's nowhere near as perfect as it is on this neat little image of a very small sample that I have on my slide here. But this is the basic idea. So going back to like the placebo versus medicine example, some people are older, some people are younger, some people are couch potatoes, some people exercise 5 times a week, some people are very, very sick with this illness that you're trying to treat, and other people are not so sick with this illness you're trying to treat. Likewise, with my study on information spreading in networks, some people just baseline are nicer than other people. So that's another idiosyncrasy we can think of. And if we randomly assign people to conditions, you can be sure that these idiosyncrasies among people are about approximately equal across conditions, turning your conditions into identical twins of each other to the extent that you can. Now, if we use some other method, like in this image where we let people maybe like choose their groups, say we give the drug to like the sickest people in our study because we're nice and we want to help these people get better and they really need it. So we give all of them the drug. Or if in my study we had groups like vote to decide, hey, do you want to be in a group where people can gossip about other people, or do you want to be in a group where people are like prevented from talking about other people's behavior? Well, if we do something like that, then we won't know if our intervention worked or didn't work because our intervention was good or bad, or because of the way that the treatment group and the control group were made up of different types of people. So our drug might not have worked, not because it doesn't work, but because we gave it to all the super sick people who were really advanced in their illness anyway. Maybe I get my next publication in Science that says information spreading works, but in reality it's because if we let people vote, the people that are going to be cool with gossip are the ones that are nice anyway and that were already inclined to be cooperative people. So random assignment is helpful for letting us make sure that we've kind of dispersed these idiosyncrasies in our participants across both of our groups. The second hallmark, the other big thing that experiments do really well, and lab experiments do in particular quite well, is procedural control. So this means that everything that the participants experience as we conduct our study is identical, except for the manipulation. So we're giving both of the groups a pill. It just differs what's inside it. Both groups are playing like an online experimental game that takes about 30 minutes. That's held constant. Oftentimes with interventions, like say trying like a program in a school or something like that, sometimes the control is just nothing. But it might be better to have like a control intervention that gives the folks in the control conditions something to do, something where they interact with researchers, spend time invested in a study, or something to make sure that there's no differences in the procedure. The purpose of this is to hold constant, not these like idiosyncrasies within your participants, but the stuff out in the environment that helps us get rid of all the third factor Z's that could be affecting that XY relationship, both the ones inside the participants and the ones outside them, because all of this stuff is held constant across your conditions in your experiment. And these two hallmarks then, combining them together, these are what helps us parcel out all of the other variables except the two that you're interested in studying, which helps us establish that causal relationship, which is the biggest strength, as I see it, of experiments. They're the gold standard method that we have for establishing causality. But now let me get into lab experiments in particular, so my focus, compared to field experiments, which are out in the wild, taking place in the natural setting, with people that are in this natural setting. Lab experiments occur in a more heavily controlled environment, the lab. So one of the things that they do really well, that's great about that, is that they allow researchers to develop and test their scientific theories in a highly controlled way. And that is really their most appropriate and valuable use, if that's what you want to do. If you don't have good theory that you want to test, then it would probably be better to collect observational data in natural settings until you get to that point. Experiments, lab experiments in particular, can complement observational data quite nicely. So if your observational data uncovers some potential process that you then would like to test causally, or if you want to test mechanisms that explain the patterns that you observed, then experiments are a really, really good way to do that. Now, of course, like a very neat and clean way of testing an abstract theory in a highly controlled setting with precise measurement is great. But it's also very abstract. And some may even say, too highly controlled compared to our very messy social world. There are pros and cons to experiments, like there are pros and cons to any method, in the sense that they do work well as complements to each other. I'll come back to those at the end, but at the same time, we don't typically tell chemists, hey, leave your lab, get your test tubes, and roll them around in the dirt, because that is the way that chemical reactions work in the real world. We don't tell chemists that. We tell sociologists that a little bit more. So lab experiments, yes, they are highly controlled environment. They're sterile and they sound very sterile. And they do deserve that reputation a bit, but they're also changing. So for example, lab experiments used to look a lot like this. So like always conducted in some like basement of a university with odd, novel, or at least novel to these participants, like technology, I guess you would call. I don't know what study this is. I tried to figure it out, but I couldn't figure out what study it is. And they were usually conducted among like 20-year-old white all men, as you can see in my images, college students, especially beginning in the earlier days of lab experiments as these were. So the second image is from like the very famous Asch line conformity studies, for those of you out there who are familiar with those, where they brought one white college man into the basement of the college, and they were interested in studying peer pressure or conformity, and all these other guys are actors that are in on the experiment, and they say like a very obviously wrong answer to a very basic question. And the question is, will this guy, the guy in the middle here, the one who looks very confused, will he conform to what these other folks are doing and say like the obviously very wrong answer? The other people on the sides are the cool, calm, and collected actors. Now, obviously, these are not situations that we are often in. These do not look like the real world. And a situation where you're called into a basement and asked to say a very obvious trivia question in front of people who are actors is not something that would probably happen to you in real life. But the findings are relevant. They tell us about conformity, and they have replicated in a variety of settings, including fairly recently. I will also confess that it was hard to find, like there are many classic studies that have not replicated very well, but that's a topic for a whole other talk. That one is one that has. Experiments on networks in my field, so sociology, have long been used to test some of the like capital T theories in sociology, which is what they're great at, including the traditions of power dependence theory and social exchange theory. So this is this is one of many examples. It's a little small, sorry about that. But this one is images from networks studied by Cook and Emerson. They've done lots of great work demonstrating that power is a capacity embedded in a position in a network. It's not just some people have power and use power and other people don't. But the folks in these networks use power in predictable ways as a result of the structure that they're embedded in, not just because of the type of person that they are. Likewise, on this bottom image here, this is another classic work, I think, Yamaguchi and Cook, in the social exchange literature. This work is showing that holding constant like the cost and benefits of exchange and the number of participants in the exchange, structural features of exchange networks, so like the way that resources and benefits flow throughout networks, where they go in the network, predict the likelihood that people will engage in cooperative exchange and develop feelings of like attachment and cohesion and solidarity to their groups. While in the messy real world, groups of people do engage in exchange like this, so they do things like collaborative papers or teamwork projects where they're giving resources to this like common resource pool, and then the benefits from that resource pool flow back. And likewise, they do things in the real world like that on the right, where like I maybe do a favor for this colleague at work, and then they like maybe pay it forward to someone else, and it comes back around to me eventually. That's the one on the right here. It's difficult to study these things in an office if you want to test the propositions behind this theory. So these folks did it in a lab in the way that's shown here. And here are some examples from my own work, to plug my own work a bit. Some of the questions that I ask and test in lab experiments. The top one is also in the social exchange theory kind of realm. It asks how social identities, when we introduce social identities into exchange networks, which are shown with like the colors on here, again, sorry about the tiny font, affects the predicted patterns of cooperative exchange that we would typically see in the social exchange literature. So whether identities are present and whether they're diverse or homogeneous, how do these things matter for small networks that are engaging in cooperative exchange? And then another recent project on the bottom here, also with Tom, shout out again to Tom, looks at how different group sizes and network densities intersect to promote cooperation in networked collective action groups. Another thing that lab experiments are really good for, aside from allowing this controlled test of theory and complementing our observational data, is that they allow us to focus on things that may be difficult to observe or measure outside of the lab, as some things are. So people wielding power, to take the power dependence theory example. People engaging in pro-social behavior is difficult to observe or measure outside of the lab, or it can be clouded by other things like whether a researcher is watching you. And then lab experiments in particular, often focus on behaviors in particular, which is another benefit. Attitudes don't always predict behaviors. There is debate about this, and attitudes certainly can be good predictors of behaviors. But there are also past examples of work that have demonstrated that there's a gap there. For example, like one of the best examples of this that I know of is Deva Pager's work. She did audit experiments where she sent out resumes to employers looking for jobs, and she found that Black job seekers, holding totally constant the resume, the job history, the education history, all of that kind of stuff, holding constant that Black job seekers were less likely to get a call back than white job seekers were, again with the same resume. Actually, this might be a bad example because it's not a lab experiment, but it is what it is. On the other hand, if they had given all those employers a call and said, hey, I'm just wondering, do you discriminate against people who are coming into your place of business to apply for a job? What are they going to say? Well, of course, they're going to say no. Right? So sometimes there is a gap between attitudes and behaviors, and lab experiments can allow us to pick up on behaviors in ways that it might be more difficult to do. We can use lab experiments to measure emotions, psychological states, decision-making, actual generous behavior, rather than just, hey, do you remember how many times you donated to charity in the past year? People misremember that, we'll say, right? So that's another benefit, I think, to lab experiments. They are also now moving outside of the lab, outside of the black and white pictures I showed you earlier, to being online. So we by no means use representative samples like surveys do, but we have progressed a bit from moving outside of the lab space to online samples. I do get many of my participants from the IBRC here at Duke. They maintain a participant pool. So it is quite a lot of college students, but this pool in particular prides itself on consisting of not just the 20-year-old college student, or to go back a little bit, like the 20-year-old white man in college, but it actually consists of a much more diverse pool than I think we used to use, including this one, which uses not just students, but also employees and people in the surrounding Durham community. Online is another way to get participants. Amazon's Mechanical Turk is probably the most well-known. Prolific emerged as a competitor shortly after to kind of address some of the downsides of Mechanical Turk. I could give a whole other talk on that, but these are just some examples. And I also don't usually run studies in the lab anymore. I use, as a result of the pandemic, I use places like these, so platforms where I can run studies online, starting with your basic bread and butter Qualtrics to Breadboard, which is Christakis particularly designed for network experiments. ChatPlat allows you to let people chat in real time, and some of these other ones I've used as well. So things have moved outside of the lab to the online lab, which has some benefits as well. So for example, you saw the images that I have of conditions in the lab earlier. Well, those were very, very small networks. Moving to online can allow us to capture larger ones. So to wrap up, lab experiments have strengths and weaknesses. They do allow us to have that high degree of control over the variables under investigation. You can isolate, you can manipulate specific factors of interest while you're holding everything else constant. That control enhances your internal validity of your study. Reducing the potential for these confounds, these third factor Z's, and allowing you to have what's really the strongest possible evidence for causality and insight into mechanisms, your moderators, your mediators. You can also use pretty precise measurement if you do a lab experiment in this highly controlled environment, and you can do it with relatively simple models. You don't have to keep throwing different control terms in there to get at the relationship that you want to get at. On the other hand, they also have weaknesses, right? And I've touched on these kind of throughout. The external validity of lab experiments is often criticized. The setting does not necessarily resemble the real world. And it's the same issue with the sample, right? So participants also don't look like the real world. They aren't representative of the population. We typically use convenience samples in the experiment. The college sophomore I mentioned, weird, so Western educated, industrialized, rich, and democratic. That's where experiments tend to be conducted, and those are the participants that they use. And the question is, does this generalize to non-weird people? And small, I've mentioned that as well. So especially as a result of lab space, before we were able to move things to the online lab, I showed you an image from a study earlier that I did that looked at small and large groups. The small groups were size 4 and the large groups were size 8. That is not really that large of a group. I would argue that it was meaningful enough to my participants because people in groups of size 4 acted differently than groups of size 8, and I had to tell many reviewers that before the paper was out. And moving to the online space can help with that as well. The reason why my large groups were size 8 is because that was the last study I conducted in the lab before the pandemic shut things down. And what do you know? The lab space that I use has nine cubicles. So that played a role, right? On the other hand, as the experimental, I'll end on a positive note and say, if you think that the lab experiment needs to go into this different setting, great, let's test it there. We are trying to test, when we're doing a lab experiment, we're trying to test our theory. We're getting that clean causal test of it, and we're doing it with the convenience sample that we have, that is true. But we also are standing on the shoulders. We're building theory, and we're saying things that I think are important about the theories that we're trying to test, and I hope I can encourage you to maybe consider doing a lab experiment with your own work. I'm also happy to talk about it because lab experimenting is very, very hard and stressful. Thank you for listening. I'm happy to take questions. Thank you.
Awesome. Thank you so much. All right, a bit like last time, I think we'd like to open it up for questions specific to either speaker or just general. Like, how do you do this work? I'm going to put a strong plug in and say that I do think that one of the things that's gotten into trouble, particularly for those of us that cycle around a lot with medical researchers, is that the other side of the school of medicine uses experiments, right? That's what they do all the time. And, they give this placebo drug or not. And we both suffer from the lack of that power and the cost of all those concerns that they have for dealing with those consistently. So I think understanding the world that it comes from, of course, is good for all of us. But more than that, I think that there's a lot of power in these methods, either in field experiments or in lab experiments, that is recognized, and your audience in the health world is ripe to hear this kind of work. So anyway, that's just my shameless plug for why I think this is a very necessary part of what we do, and I'll open it up for questions.
I appreciate the shameless plug. Yeah.
Please.
So I do a lot of online experiments, and one of the criticisms that I have found has been the inability to control all those exogenous various factors, because especially like using chirp prime or the prime panels, versus mTurk itself, the sample that you get, at least what I've seen so far, is still like your mid, like the 30, 40 white woman, $45,000 a year income population, but there's a lot of you're taking it at home, you're taking the survey or the experiment at work, there's a lot of things that you're not controlling for. Some would say that, well, you just increase your sample size to try and drown out the noise or the error. And then some others, like Shane, are like super against online experiments. Can you speak to that at all?
Yeah, so on the one hand, this is more of an issue for you as the experimenter, I think, and less for the critics and the reviewers, because if you do have people, yes, who are at home, and I've had that issue moving to online experiments where it's like, I do these repeated tasks that happen, multiple decisions over time, and you get these issues where someone just gets up from the group task and they go make a sandwich, or they go to the bathroom and everybody's sitting there waiting, or they just disappear, they lose internet connection. I kind of miss that aspect of lab experiments where you could frankly control what they're doing. You know exactly where they are. You have tabs on them, right? You know they're in a quiet environment and all those things. That does become more of an issue for the experimenter. So how do I design my experiment to reduce the effects that is my experiment ridiculously long? Is it boring? Are there other things that I can do to try to make it so that these things play less of a role? How engaging is the task, for example? Other than that, yes, increasing your sample size to get at the fact that there will be noise. But if you find a difference between your conditions, then you can't say that this is due to one group of people having more children running around in the background than the other, because you would have randomly assigned that. I definitely also come across some folks that are, I don't know, I feel like there are probably less people than 4 years ago that would be very anti-online experiments anymore. Like, we didn't really have a choice but to switch to online experiments as a result of the pandemic if you wanted to continue data collection. So I do know that Shane is very against online experiments, though, to give you just a personal note. There are pros and cons to both methods, I guess is what I would say. Do you want to?
Yeah, maybe I'll add something. Thank you. So it's a really interesting question, and I've been thinking about it like philosophically, and I'll give an example from the public health context that I think kind of relates to this question about the pros and cons of online experiments versus observational research versus maybe field experiments. And it's the research on BPA, which I think a lot of public health people would know about. Does BPA cause cancer? The early evidence was all from epidemiological studies. You had these large-scale, Deborah Davis, large-scale correlations between plastic use and cancer. But there's no causality there. There's no mechanism there. There's an interesting correlation. And then what do? You say, is there something going on? And so you have mice studies. You basically inject BPA into mice. And you say, oh, wow, these poor mice are, now kind of getting cancer. And then, someone would say, well, mice cells aren't human cells. Mice are built to last for a year, 2 years. That's what their cells are. Human beings live for 80 years. Like, there's no one-to-one. Human cells may be much more resilient to BPA. And obviously you can't inject BPA into humans. So then, people started developing ways to grow human cells, non-cancerous human cells, in petri dishes, so they can basically, think about whether, BPA actually causes cancer. You can't really tell because it's not a real human. It's a human in a petri dish, completely isolated from the rest of the body, rest of the immune system. But the first evidence of BPA actually causing the first set of chain reactions to causing cancer in human cells happened in 2013, long after we knew that BPA was dangerous. And so I think about the methods that we use as a community of researchers as a process of triangulation, all right? So what things that can you get from online experiments? They're cheap, right? They're very, very cheap. So you can try out lots and lots of ideas. And so you have a distribution of ideas where you have a lot more promising ones and less promising ones. you have observational research, which gives you correlations that say this is interesting, and field experiments are expensive. I mean, from my own experience, they can be hundreds of thousands of dollars. Like my last experiment was 250 grand. And it was still a pain in the neck to publish. And compare that to other people who have sample sizes of 17 or 25 that are $1 million experiments. You're going to test the theories that have the highest probability of being true in a field experiment. I think this idea that this research is bad because of this method is a misunderstanding of the scientific enterprise. I think we have to think about this stuff as how do we all contribute to knowledge that in different ways. Is it generalizable? Can we test out a lot of different ideas, say something about mechanisms, and does this work in the real world? So that's what I wanted to add.
I love that. I love that emphasis on useful, contributing, and triangulating things.
Next question. Please, yeah.
Just following on that, and I really love the example you gave earlier about how so many of us who work in the same space don't work or know each other, right? I think I'm reflecting on the 17-year gap between when we first struck these experiments and these trials and then implementation and policy practice. I would love to know from you all, what are recommendations or best practices for that active triangulation and that active collaboration on the co-op networks, like people on these grants that are doing, maybe some doing field experiments, some doing lab experiments, and just thinking about a hybrid model so that we are not, for example, potentially just sort of working on lab experiments, feeling good about it, and then trying to do fields and taking a lot of time, but just being nimble with that. I would love to hear from you.
So I too thought that paper was really interesting, and honestly kind of relate to it in my own work. I don't know if this is working. And I'm reflecting on my own work as a result of it, and so much of my own work is pure lab experiments. I have a couple things out there that rely on other methods, but not nearly that much. So I honestly would just agree that I would be excited, and I mean I think that's why this opportunity was so cool, and coming here and hearing about different methods, hearing about field experiments, lab experiments, and these other ways of doing it. Thinking about this as a triangulation problem, thinking about building networks, so that more of these kind of collaborations that use multi-methods, because that really is I think the true answer is that the best way to go about doing this is to use these multiple methods and rely on the strengths that they have and allow the weaknesses that they have to be addressed by one of the other methods. So the question is how do you do that? And I don't know that I'm the best person to answer that, because so much of my work is lab experiment.
What should we be demanding?
My work doesn't speak to health. So we, in the context of field experiments and innovation or entrepreneurship, that's my area. We actually started a conference about 4 years ago, actually 3 weeks before the pandemic started. So it was here at Duke, we held it here at Duke, and it was great. We got about 80 people in the room. We're now at our 4th year. We're holding it at Harvard. If anyone's interested, it's cfxs.org. So we basically get a bunch of people together in a room, people who do observational research, serve as discussants on papers, people do lab experiments, and so we are in the business of trying to create a conversation. I think that's a big idea, and we get policymakers, funders, and I think what I found is there's kind of a lot of collective. I think the publication process is a potential barrier to implementation. I think there's I'll speak to management research and a little bit to sociology. I don't know much about the public health context, but I think there's an overemphasis on theory, and I don't think people know what theory means. Often in that review process, it's kind of like, has anyone seen The Princess Bride? Inconceivable. I don't think that word means what you think it means. And it's kind of like that with theory as well. And I think that can often get in the way because people have these words that they say that mean different things in different fields. And so part of it is just getting us on the same page in terms of language. And I think that's kind of what we're trying to do is, and then you can start getting breakthroughs because the policymakers speak a different language, the lab experiment people speak a different language, we speak a different language, you know. And so getting kind of a shared language may be one way to like break through that impasse.
So stepping out of my role as moderator, I have two substantive questions that I'd love to hear your reactions to, and other panelists as well. The first one is just really practical. Like, what do you do with your IRBs? Like, what are the road signs that all of us that might want to jump into some of this kind of work? I mean, you and Chris make it look easy. It's like just fire a mechanical Turk and off you go or something. But I suspect that it's never that easy. And I'm just curious, you know, if that, you know, if you have any advice there for us as a group. And the second one is, I think there's this whole field that you alluded to, which is replication. And part of that comes from this idea that I think, at least the impression from the outside, is a lot of the procedures that go on in experimental work are very particular, and so you control everything, but there might be a lot of things that you control that are implicit to the understanding knowledge and the practice of the community that does it, and someone new comes in, they don't know that, and they end up not being able to replicate it. And I don't know if that's actually a problem with them just novices getting the field, and don't know what they're doing or what. So I'm curious, my guess is that these two problems are linked because they're all about procedures, but I'm just curious if you could just help us understand those ideas a little bit.
So speaking of things we should be demanding, the IRB. The IRB, in my experience, it's painfully slow. It's so painfully slow, and it wasn't always like that at every previous institution. And I know that they're making some changes to improving it here, but filling out like a Word document and the wait is long. Is painful. I don't even know how it goes with field. I don't even know how it goes with field experiments. I feel like that would be much even more slow and more painful. For me, it's probably nowhere near as slow as it is for you. I typically, one issue that comes up in lab experiments is the deception issue. Do you or don't? Do you need it? Do you not? I certainly have done studies in the past that rely on deception. That requires a much more extensive IRB review. You're not like exempt if you're using deception process. I've stopped using. I don't use deception as much as I used to. Partly because I tackle questions that don't really rely on deception, or I've figured out other ways to kind of get around the deception issue. Also because some field, like econ, you know, if you want economists to like you, maybe you don't care. I don't care. Then you don't want to use deception because they're very against deception, not because of the potential harm to participants, but because it contaminates the pool of participants. They won't trust us as experimenters anymore. If you use deception. So I don't rely on deception, which shortens the IRB process quite a bit for me. And yes, it is a little bit more like, all right, I have this idea, I fire it up, I get it ready to go. It takes some time, but then I can fire it up. Field experiment, I don't know, do you want to talk about IRB stuff?
So I'm on the IRB,
Okay.
and I'll say the slow part is just because I think people are overwhelmed. There's not enough people to do the reviews.
They're very understaffed.
Yeah, they're extremely understaffed. So hopefully the technology problem will get solved soon. They're rolling out a new system. But I'll say in the how to write an IRB that will get through easily. Be clear. I think there's a problem sometimes that researchers write these like crazy omnibus IRBs where they like include literally every variable under the sun. And then it's like, whose interests are you serving? Are you serving the interests of the subject, and these are human beings and you're not paying them really much? And so you have to really think about, I think, having been on the other side and now on this side, I definitely think a lot more from the perspective of the subject now than I did ever before. where now I'm much more, even in my own work, like what are the 5 things that are most important to me as a researcher, and how do I balance that off with the interests of the subject? If I'm basically taking more than I'm giving, I think I rethink it. So sometimes when you see IRB applications where a researcher is asking 875 questions, like that's going to get rejected. Or it's not going to get rejected, it's going to be pushed back and it's going to take time. So be much more precise in what you want out of the study. Be clear about the intervention, what you're doing. Clarity is, I would say, clarity and simplicity are the ways to get things through. I think it makes it easier for the reviewer, and it also makes it clear that, what is the IRB for? The only real reason is you're not harming human beings. And so I would say that that's probably for field experiments. I think my experience as a researcher was the pushback, and I'm much more appreciative of it now, is it too much of a burden for the, so simplicity, I would say simplicity is a key thing. Just be simple and have it, and I think the other thing that helps nowadays is pre-registration. In my opinion, I think everyone should do pre-registration. I think it just makes it so much easier. Most of the stuff is never going to end up holding, but I think it just gets your ideas on paper, and that can be a great template for the IRB review process.
What is pre-registration?
What is pre-registration? Oh, please. Okay. How many people know what pre-registration is? Okay. So great. So about half the room, and so pre-registration is something that lots of different fields are beginning to demand with experiments now, which means that you have to pre-register essentially the whole protocol down to the data analysis and what you expect your effect sizes are going to be and why, so that when you actually analyze the data that comes out of the experiment, you are not violating, a given p-value is a reflection of this one test being done in a statistical term. And so if you test like a million different things in your regression, those p-values make no sense whatsoever. And so pre-registration basically binds you to testing a specific set of predetermined hypotheses. Yes, things you may discover after you do the experiment are true, or through exploratory data analysis, but it separates out things that you believed as a researcher to hold in the data before you did the study, and things that you found after the study was done, and it kind of creates this clean separation, so you're not making up random stories based on some random correlations you found afterwards. So that's the goal of pre-registration, is to kind of bind your hands so that you don't make up stuff.
And there are now
AsPredicted.org is a user-friendly one.
Yeah, that's what we
is
use.
what I use. Yeah.
I talked over you.
I was just going to plug AsPredicted. That's the site I use for pre-registration. It's super easy and user-friendly. I also want to touch on the thing you said about how you maybe see researchers shoving like 800 items in their experiments, quite possibly just to see what happens. I've worked with a couple like undergrad RAs on their honors thesis and things, and they are tempted to do stuff like that. They're like, and then I'll throw in this like personality survey and like this like measure of their state anxiety and this, that, and the other, and items about their income. It's like, well, they're undergrads, and like you don't necessarily need these. You're doing a lab experiment, so why do we need these? We take them out. We don't need them, because I am on the side of like very simple, short and sweet, as we talked about. Like, you'll lose the online participants if you ask them 100 bubble items. So I'm very much on the side that you are with regards to that, because that again, like, we can rely on the power of the experiment. We don't need the control for all of these things. That's the whole point. We've used random assignment. We don't actually really care what their personality items are. We put them in their conditions.
I guess my one question, or like kind of caveat to that, is like, wouldn't you want to have more proximal outcomes or mechanisms that you're measuring that you might not capture the primary outcome of interest, but you may capture that first mechanism, because pre and post, you weren't able to see the full, effect of your intervention because you haven't been able to longitudinally follow them enough, but you can see that there may be changes in mechanisms that could in the future lead them to those outcomes.
Yeah, absolutely. I definitely think that, I think the point is more to just to think carefully about whether you need 800, 5 scales of this, that, and the other thing that you just want to put in your IRB just because you think you might want them. But certainly, if you're thinking carefully and you think, in my talk I alluded to the baseline proclivities to prosocial behavior. I often take a measure of that at the beginning of my study because I genuinely think that it's important and it really should be there. But when we're thinking about do we need their astrology sign and their all this stuff, it's like we definitely don't need that, but we don't need everything under the sun. There is a temptation, I think, to capture as much as you can because you're paying these people $10, but there are downsides to that, and so yeah, I would agree. I absolutely agree with that. The other issue was the replication. So we stuck on the first question.
Right, which is fair. But as I said, how much of the replication bit do you think is essentially, there's the pre-registration side and there's the p-hacking side and all this, but there's also, I think, unique to experiments that you are engaging in an actual procedural process. And some of those processes, maybe you sort people to the left side of the lab or the right side of the lab. And I don't know, which ones matter, which ones don't, and how do you know?
So there's kind of 2 reasons that you could have a replication problem with the study. One is that the original study engaged in these questionable research practices that we use pre-registration now to try to avoid. So they just continue to collect data from subjects. That's why you pre-register your sample size. They continue to collect data from their subjects until the poor RA who was supposed to run the t-test or whatever, it's P is 0.04 or whatever it is, and then you stop. That is what pre-registration is intended, and that's a questionable research practice. That's one reason that replications have failed is because people were doing these sample sizes of 12 participants per cell, and they just kind of stopped when they saw some cool result that they could publish. But then, the other one is oftentimes if someone tries to replicate your study and it doesn't replicate, you can argue that it was a conceptual replication, but it wasn't a procedural replication. Where did you do it in the lab? Did you use my exact same questionnaire? Did you have the exact same gender makeup or this, that, and the other of participant? It gets back to the same kind of game that we play with. What about this control variable? What about that control variable? I think there are probably, and I might argue that if one of my studies failed to replicate, but at the same time, that's valuable to know. That kind of replication helps us address one of those issues that critics have with experiments, which is that, well, what does this really tell us about the real world if it doesn't replicate unless you're doing it in the lab chairs on the left or this, that, and the other? So if it doesn't replicate, that's important. It suggests that we at least should do more research because even though our experiments do rely on all this procedural control, it's not a good sign for our theories, even if it comes down to something so simple as where you're sitting in the lab or whether it's hot that day or something like that.
So maybe I have a couple of thoughts on replication. So let me start with the simplest one. I think part of it is, what do you attribute to the lack of replicability? And it's not just a psychology problem, it's not a sociology, it's not economics, it's everywhere. You see this in medical studies, you see this in so many different studies. And so, I try to go with the simplest explanation for this, and I think I've come down to 2 for why we have a replication quote-unquote crisis. One is, I think people are just not well trained in statistics. And I think, most people get very, very extremely applied training and they don't know how to think statistically. And so I think that's one thing. So I bet if you were able to include a control variable in what studies get replicated or not, about how good this person's education was in statistics, I would imagine this would explain a ton of variation in what stuff replicates or not. That's my simple one explanation. Number 2 is incentives. And I think the desire for novelty and volume creates a incentive problem for researchers and if you think about Mechanical Turk as a great example, what is Mechanical Turk doing? It is dramatically lowering the cost of running an experiment. And what happens if you put on your Econ 101 hat, when you lower the cost of something, more people do it. And so the next Mechanical Turk experiment is going to be lower quality because the people who are going to do an experiment when it's hard are people who have higher ability. And so as soon as you lower the cost of something, the marginal experiment is going to be less good, is kind of my thought. So I think the incentive issues and the training issues are, I would say, primary. And then I think at a more philosophical level, do I want less diversity in research where we're so strict about, I think the way that these replication police have taken, I think it's actually disruptive to research, in my opinion, mainly is because I think we should never take one study ever as truth. The truth comes from lots and lots of studies. That's great. I think that part of it I agree with, but then destroying people's careers because one of their studies didn't replicate, I just think that's foolish and kind of bad for the research enterprise. What you want is actually more diversity, people trying different things, and assume that some of this stuff's not going to work. That's how we get, we want more diversity, not less diversity. That's my philosophical thing about it, yeah.
I mean, I just to follow, I agree completely. One of the things that we've argued, some of our work on the observational replication is that one of the disadvantages of the replication police model is that it puts all of your reputation on the line, right? But what you want is the incentives to be flipped. You want people to, get rewarded for finding mistakes in their work, for putting out a retraction that they need to or whatever. So if it ends up being the case that your career is shot because you happen to make a coding error, like that's not the incentive structure we want at all, right?
If that was the case, radio would not produce Kid A.
Right.
So, right? We want diversity.
So in the field of autism, there's several RCTs that are being done, and it's a way in which some of these interventions that are being done in the field are tested, and there's a growing critique in the field of RCT studies in autism, and one of the big critiques that people make is that if you invent an intervention, and if you run the RCT on your intervention, that it's not a good idea. It reduces the quality of it, and they're even now seeing that when, a lot of times in autism we have to do a multi-site design because getting your sample is really, really hard. So they're seeing that the effect size is higher for the site where the PI developed the intervention and they're doing it. And so isn't that like, evidence that it's because it's their intervention, like that's what's causing it, or is it the fidelity is just higher because they know how to do the intervention, but I'm just wondering what your thoughts are.
So that's a great question. So there's a lot of stuff that's kind of inbuilt into that question. So let's start maybe indirectly answering it if it's okay. Hunt Alcott has a great paper looking at treatment effects in the field experiment on energy saving. And basically he finds that sites that select into participating in the experiment actually have a larger treatment effect than they would if they hadn't selected. So there's something about selecting into a willingness to actually do an experiment in this energy context. Actually, that information increases, there's like an invisible interaction effect where the people who said yes to doing the study are actually the ones that are likely to get a higher treatment effect. So what you have in your context in autism is basically this invisible treatment, heterogeneous treatment effect, which is are people who are willing to participate in the study or have designed the study, do they have a larger treatment effect than would be in the general population of possible places where you could do this autism study. Am I framing that correctly? And so the reasons could be they follow the procedure better, or they have a lot of tacit knowledge about how to implement this that may not be reflected in the procedures. I think we don't know anything about that. That's the huge new frontier of the extent to which treatment effects actually vary based on site. So, and why? And lots of reasons exist. Tacit knowledge, following procedures, more interest amongst the subjects to actually go through with it. And to be honest, I think the research on this about why that's the case is super minimal. And it's interesting this is happening in autism research as well. So Hunt Alcott is the person you should check out the paper from that speaks to this issue of why are treatment effects larger in some places versus others.
I just wanted to reflect, I think implementation science is really focused on that, right? And that's really that transition from research to practice and figuring out why we don't replicate when we're translating this into practice. So it's thoughtful, maybe practice informing research, because there are all of these frameworks, right, in terms of implementation drivers like knowledge, as well as contextual theoretical drivers that have nothing to do with the delivery and all of that. So it's exciting to see kind of multiple parallel trains of thought.
Yeah, I hadn't made that connection to the implementation science, but it's exactly right. Yeah.
All right, folks, I really appreciate our speakers. Thank you so much.